40, 55, 40 to 50 miles an hour, and they are as heavy as you could ever imagine. The steel on these things is super thick, but it's pretty cool to see. The next one I wanted to talk about is a program that I work on a lot. Oh, another question, sorry.
How many are in use aircraft?
How many in use?
Yeah.
That's a good question. I would say what has happened is, so force protection, virtually every country in the world now is buying these vehicles from force protection. So whether it's Australia or the UK or the Russians or whoever, they're buying a lot of these vehicles. So this company's doing really well. I would say they're in the field right now. There are probably about 2,000 of them, give or take, about 2,000. And actually, the problem for force protection as a company, they were really a very tiny little group down in South Carolina 5 years ago. And because of all this demand, they have exploded. Their growth has exploded, and they haven't been able to they haven't been able to hire enough people that have the right kind of training and the right knowledge, and they've had a really hard time actually manufacturing these in a way that they're the quality that they expect them to be, that they want them to be. So what would happen is if they got it overseas in Iraq and it was in a desert somewhere, and if it broke down, they didn't have any way to get them the information to how to get it fixed. And so as a company, they've had to focus a lot on not only, okay, now we got the design right, and how do we service it once it's in the field? Okay.
Could they be helpful, like you said, they're going out to Australia, right?
Yeah, they're everywhere, yeah.
Would they be helpful in other situations like the flooding there? Or is it mainly just for bombs?
Well, it's essentially designed to move people safely. And so anyway, it's an SUV on steroids, so to speak. So yeah, it could move anybody. It's a very, very safe vehicle, independent of whether there's a bomb or not.
What's the thing on the top?
In that picture, well, lots of times it's a gun turret.
Oh,
I can't tell if that's what it is on that one, however. But a lot of times it's a soldier up there with a gun. That might be a light. Can't tell. All right, so the reason I talk about the Bombardier C-Series, first of all, is because I spent so much darn time working on it. But more importantly, for you folks, this is a design that is revolutionary for aircraft. And the idea, again, is to use less fuel and to be able to be much, much more efficient. The key to this aircraft is the material that it's being designed with and the engines. The engine, it's a brand new engine concept developed by Pratt & Whitney in Connecticut, and it's just a much, much more fuel efficient aircraft that we use, that's good for the environment because it's using less gasoline. The design process for this aircraft is also unique and has never been done this way before. The wings are being designed in Belfast, Ireland. The fuselage is being designed in Shanghai, China. The cockpit is being designed in Montreal. The electronics are being designed in Italy. All the different components of this aircraft are being designed in different parts of the world by different teams, by different languages, in very complex situations. And then what will happen is they'll individually be shipped to Montreal, Canada, and then Bombardier will assemble them all together there. And then Bombardier will have the responsibility to service the aircraft as once it's deployed for the airlines.
Since they're doing different parts in different areas, how do they do like the measurements to make sure that they're the same, like which units?
Well, it's a perfect question, and one, frankly, that they wish they could answer a little bit better. They're having a really hard time making sure that everybody's working on the same data, and to your question, the thing that gets the most complex is what happens if I'm designing the wing and I make a change to my design. That change to my design impacts all these other elements of the aircraft. Every change has a ripple effect through other parts. And so how do I communicate that change? And the answer is through collaboration, through really effective collaboration tools that let me know, it highlight me on my computer or throughout the entire system. And that's what our company does, is helps manage the change and the collaboration process for these companies. But at the end of the day, there's no set answer, frankly, until they put it all together.
Is it the same size as the airplane that was flying today? And will it run the same way? Or
Yeah,
essentially
it's
horizon?
another good question. I should have expected a really good question, shouldn't I? That's a great question. This aircraft, when you look at the airline industry, a lot of us have flown, if you've flown these really little planes here in Raleigh, if you're going to New York or you're going to Washington, D.C. or somewhere, you're not going very far. Those airplanes are proving to be not very cost effective for the airlines. At the same time, the airlines have these massive airplanes, the 777 and the A380 that hold hundreds of people. Those planes have a place in the market because they'll fly from here to London or from here to Paris or wherever. But the in-between market, the airlines need a new airplane. This airplane will hold between 100 and 150 people. And this, they believe, is the size airplane that the airlines can actually run a good business with and fly the airplane efficiently, more cost effectively. So this is larger than, they call them regional aircraft, and like I said, if you've flown out of RDU, usually they have the small regional aircraft. This is bigger than that, but smaller than the great big jumbo jets. Did I answer your question?
Yes.
Okay. And it's all about, for the airlines, their ability to make money as companies, finding the right size plane that's efficient for them.
How is it taking less fuel and still fly about as efficiently as the one that takes in more fuel?
It all has to do with the new engine, the way that they designed the engine to burn fuel more efficiently. So it's the same size engine, same virtual size aircraft, but the way the internal combustion of this engine that they've created is more efficient. Okay. And the last one I have is Lockheed Martin, in conjunction with the U.S. Navy, has created something called the Littoral Combat Ship. This is as it's being launched about 3 months ago for the very first time. This ship is called the USS Freedom. And this ship, if you've ever seen, have you ever been to the USS North Carolina down in Wilmington, or seen ships like that? This one is actually quite a bit larger than those. And the USS North Carolina, when it was in service in World War II, had nearly 2,000 men on it. So you can imagine how people were stacked in there. This ship is larger, but will only have 50 people on it. This ship is almost, in a way, in our layman terms, is a remote control ship. It is going to be driven and modified and manipulated from shore. And that is a really unique concept. It's never been done before with a vehicle of this size, with a ship of this size. And the other thing that is really critical for this is it goes in shallow waters. It's more focused to be around the shores of companies, not way out in open sea, although it can do that no problem. But it's better designed to go into shallower water. And it has more to do to help us with problems with terrorism. Terrorists are more, they're not out in open sea, they're going to be more closer to the shore, closer to cities, etc. And this is another design that is hundreds of companies are taking part in. And again, Lockheed Martin in this case, they're just putting the final assembly together. So each individual component, and I had another slide that showed the different companies and the different countries that are taking part in the individual design. But it's all about the collaboration and managing that whole process.
How fast does it travel?
This goes, I think, about 40 knots. I don't know how that would equate to miles per hour, but something that big, that's moving. That's going really fast.
Or does it look like it's about to tip over?
If you can see, well, this is when they put it in the water for the very first time. It was on this dock or this lift, and they lifted this part up and dumped it right in the water for the very first time, and it made that big splash. So it almost is tipping over.
Where did the Navy and the company design this?
Yeah, it's designed primarily in Morristown, New Jersey, right next to Philadelphia, and Marinette, Wisconsin. Also, I would say Syracuse, New York, and Baltimore, Maryland, primarily. Yeah, that was. Okay. So my last couple minutes, I want to talk to you a little bit about, so for my company, while we don't necessarily work with students, my company in particular, but we believe it is critically important that the students and kids of today have the necessary skills and knowledge and interest level in math and science, so that if you're focused on it today and you're really thinking and learning the right way today, you're going to become the top flight engineers of tomorrow, the people that are going to be designing the next space shuttle and the next C-Series from Bombardier, et cetera, et cetera. And like I said at the beginning, this really all does, frankly, come down to math and science. I mean, the understanding the math behind these designs and how to create and visualize some really complex and frankly fun stuff to work on. So we as a company focus a lot on this problem. As part of it, we are a big part of the FIRST initiative that I talked a little bit about earlier. FIRST has several different elements to it. For young kids, there's a Lego challenge for kids 6 to 9. For kids your age, there's the FIRST Lego League, and it's a competition creating different designs and using Legos and electronics. And then as you get into high school for ninth grade and beyond, 9th through 12th grade, we have the FIRST Robotics competition, which is, I actually have, well, this is a little bit about it. What you're doing is you're in teams of 10 people. You design and build and program robots. You're given all the materials by the FIRST organization, and then you're competing against teams from all over your area and then all over the country. And what you're doing is you're applying all this real-world math and science information that you're learning here at Carey Academy and putting it in real concepts. Obviously, it develops problem solving. Because you're working in teams of 10, you have to be able to be organized and collaborate. You can earn a place in the World Championships. And then lastly, last year alone, through the FIRST Robotics competition, over $7 million of college scholarships were awarded through the competition.
Is anybody in here in the robotics club?
I wasn't
Wait,
it.
you are, right? Lincoln?
I wasn't it.
Okay, yeah, so I have a quick video. I don't know if you're going to be able to hear this. Are we okay on time? This is 3 minutes.
Yeah, you're fine. I can plug in if it reaches the audio line. That would be in there.
Well, we can do this. Okay.
Science and technology drew quite a crowd at the recent Boston Regional FIRST Robotics competition. Massachusetts high school students competed against each other using their entirely homemade robots. In this year's competition, robots must circle a track and gain points by completing different tasks. Teams get a different number of points by just running laps, more points by lapping the track with a ball, more for throwing the ball over the overpass, and the most